Hello, my name is Les Ross. I'm the president of EVKeg Corporation. Heavy emphasis has been placed on keg safety by the brewing industry due to recent failures that occurred with plastic kegs that were accidentally overpressurized. The purpose of this video is to outline the safety features that have been designed into our EVKeg. The engineers at EVKeg Corporation come from a wide background of experience in designing high-pressure valves that are used in the semiconductor industry that typically operated at pressures in excess of 4,000 psi. We've fallen back on that experience and that knowledge to design unique features into our EVKeg that we believe makes it one of the safest kegs on the market. When we look at all the potential causes of what we call catastrophic keg failure, we can narrow that down into three areas of concern. The first of which is the use of a welded joint to connect the top and bottom halves of the keg together. The second of which is specific to plastic kegs, and that's the drop performance of the keg at low temperatures. And then the third concern is obviously the concern of overpressurization. When we looked at how we were going to connect our top and bottom halves of our kegs together, we considered a welded joint. But again, falling back on many years of experience of welding stainless steel, we realized that there are a lot of variables that are associated with the manufacturing process to create the weld. Variables such as cleanliness of the material, the setup of the weld joint, the parameters of the weld itself, the speed and the heat input, and then obviously the skill of the operator that's controlling that process. When we looked at all those parameters, we just felt the risk of a failure occurring because of lack of control of that manufacturing process was just too high. And as a result of that, we decided to use a threaded connection to connect our top and bottom halves together. We use a large thread that's very strong, very robust and durable, and is able to withstand a lot of abuse due to inappropriate handling. But the key thing about the threaded connection is that it is not susceptible to a lot of variation in the manufacturing process because it's essentially created during the injection molding process of our halves, and we can easily verify the integrity of the thread through dimensional inspection. Whereas verifying the integrity of a weld occurs by visual inspection of the weld profile, which is very subjective, and then possibly through the use of a pressure test, typically taking the keg up to a proof pressure test of around 90 psi. When we look at the pressures that cause the failures of these plastic kegs, those kegs failed at pressures above 100 psi. So a proof pressure test is no guarantee against a potential failure if the keg is accidentally subjected to pressures above that proof pressure level. The second area of concern was associated with the keg's performance, drop performance at cold temperatures. As you know, when you reduce the temperature or lower the temperature, plastics become more brittle. The material that's used by most of our competitors in their kegs is polypropylene. And that's because polypropylene has very good high temperature performance, which is necessary for keg cleaning. However, at the lower temperature ranges, especially if the kegs are brought down to temperatures around freezing, it has very poor drop performance and is likely to fracture if a keg is actually dropped off a truck at temperatures around freezing. Now, our material, on the other hand, is polyethylene. Because we don't have to clean our kegs, we're not so concerned about high temperature performance, but polyethylene has very, very good mechanical properties at low temperatures. So even at temperatures of sub-zero, we're going to have a very, very good drop performance, which would avoid any catastrophic fracture of our kegs. Final area of concern is obviously overpressurization. Now, the first thing that we have to design into the keg is the ability to handle the typical operating pressures that the keg's likely to experience. In our keg, we followed the pipe standard, which is a standard that's used to design and manufacture polyethylene pipe that's used in water sewer systems and gas pipelines. The result of using that standard has made our wall thicknesses and our wall strengths stronger than typically of those used by our plastic competitors. But even though we have the integrity, the mechanical integrity of wall strength, that still doesn't guarantee against potential overpressurization. Even a stainless steel keg that has a very, very high tensile strength can fail if the overpressurization pressures are too great. So really, when we reviewed that, we felt that the only way to avoid that was to design what we believe is unique to our keg, and that is a relief valve that's designed actually into the head of the valve spear. And this relief valve will relieve at pressures of 55 psi. So our kegs will never be subjected to any overpressurization above 55 psi. If they are accidentally overpressurized, relief valve relieves. Once the pressure is brought back down, the relief valve automatically resets itself and the keg can go back into service. So that feature alone, we believe, makes our keg one of the safest kegs on the market. Now, other concerns, obviously, that's unique to our keg is the fact that we have this removable spear. Means that there's a potential for that spear to be turned or disengaged while it's under pressure. Well, a couple of features that will prevent that. First of all, if the keg is at pressures that are even as low as 1 psi or 2 psi, it's almost impossible to turn the handle by hand because of the friction that's being generated under pressure. But even in saying that, we have a safety feature which is a mechanical lock that once you install the liner and turn the handle, that lock snaps in place and you can hear it snap in place. And then we also have a visual indicator to verify that it's in the correct lock position. And once that snaps in place, it's impossible to unlock the valve by hand. The only way that valve can be disengaged is if the pressure the keg is totally depressurized, and then using a screwdriver to lift and disengage the lock. Once you've got that situation satisfied, it's only then that you can disengage the handle. So I hope this video has given you some food for thought when comparing our kegs against other competitor kegs. And if you've got any questions about our design or safety features, feel free to email us or give us a call. Thank you.